Hello everybody, my name is Carsten Schütz, I'm Head of Sales at Yoga Technology, and today I'd like to give you some information about the risks that come along with 3D post-processing. Those of you that already manufacture additively know quite well that the 3D printed parts don't come off the machine ready to use. You always have to do some kind of post-processing. Most of the time it's manual post-processing that you have to do. What makes it so very demanding is the wide range of different material that is used in 3D printing. You can have very soft materials, for example rubber, and you can also have very hard material, for example steel or titanium. That's why it is not possible to do the whole post-processing with one single tool. You will have to work with different tools, and that is why you can't do the whole post-processing steps in one single machine. Moreover, you have a wide range of different steps which you might have to do to get to the final results in surface that you want to achieve. That depends on the manufacturing method, of course, and also the material that you use. You might have to do depowdering, cutting of the panel, support removal, of course, deburring, grinding, milling, the finishing, and also cleaning. So you have several steps to get to the final result. Every user knows why there are post-processing related risks for the 3D printed part itself. Most of the time we don't have to explain why, for example, working with hammer and chisel to do the support removal may cause damage to the printed part or even destroy it. What most of the users don't know, or maybe just don't realize, are the post-processing related risks for themselves, for their health, and those can be quite severe, so we have to talk about them. There are several risks coming directly with the post-processing. For example, when you do deburring, you produce sparks, and of course you don't want to get in touch with those. That is even more important when you work with titanium. The sparks that you produce are extremely hot, and it is very unpleasant if one of those sparks touches your body directly. When working with powder beds, you got extremely fine powders and extremely fine particles that can be easily be inhaled, and they go deep into your airways. It doesn't matter whether you're using non-critical materials, for example plastic, or critical materials, for example titanium. You don't want to have those particles in your airways. With the post-processing you also produce dusts, for example when you do grinding, and those dusts are even finer than the powder itself. They are highly respirable, can easily be inhaled, they go deep into your airways, and since your body isn't able to cope with them, they stay there and can cause severe damages. You can see from this illustration how deep different particles with different sizes can go into your airways. Well, some of you might say now that since you're working most of the time with particles from 10 to 60 micrometers, they will be no problem. What you have to keep in mind is when working, for example, with a powder 10 micrometers, that is an average value. You've got particles much bigger and also much smaller than this average value. So you can also have particles from 5 to 10 micrometers. Moreover, as I said before, when you do the post-processing, such as grinding, you produce dusts, and those are much, much finer, and they go really deep into your airways and they stay there. That is what you always have to keep in mind. So You can't be careful enough. When working with reactive materials, you also got the risk of ignition or even detonation. Reactive materials can be, for example, titanium or aluminium. And as you can see from the next sheet, dust explosion can be easily caused. What you need are flammable dust particles, of course. When working with aluminium or titanium, you surely do have them. Then you need a particle size smaller 500 micrometers. As I said before, most of the time when working with powder beds, you do have sizes from 10 to 60 micrometers. So here's a check as well. You need a dust concentration greater 20 gram per cubic meter. You also can easily cause that and can easily have that concentration, since you always do have many powder in the structure itself, in the support structures, and in the 3D printer itself. The explosion is prevented by using inert gas. You don't have that when you do your post-processing. What you do have is a normal oxygen level. You need 21% oxygen level for a dust explosion. That are normal conditions that you do have. And then, of course, you need some source of ignition. That can be a spark coming from your post-processing, for example, grinding. But sometimes the mere friction between single particles can be enough for an ignition source. That is why you have to watch out what you're doing when you're doing the post-processing. Apart from the direct risks, you do have long-term risks. Those are even more critical, since when they come up, you can't go back in time and do something about it. You can have skin irritation from contact with dust, with powder, with sparks. And if after years of doing 3D printing, you only do have skin irritation, you are really lucky. More dangerous are the airway diseases. From inhaling dust, from inhaling powders, you can get asthma. You can even get a black lung. And as I said before, since your body isn't able to cope with these particles, they stay in your airways, they nest there, and that is why that can cause cancer. So our advice is, please always take a good look at the safety data sheets of the materials, of the powders that you use. Make sure that you store powder safely. Observe the safety rules in every step, not just in the manufacturing progress itself, but also in the post-processing. Make sure when you do your post-processing and you produce dusts and set-free powder, that all the critical particles are immediately sucked away, and that they are also collected safely under suitable conditions, for example inert oil. Of course, you have to make sure that you do have a proper waste disposal, and what that means for your country and your region, please ask your disposal contractor. So that's for today, what we wanted to talk about. If you do have any questions concerning tools for post-processing or our Inesca PostPro, the workstation for safe post-processing, feel free to contact us or visit us at our shop, yokatechnology.com 3D shop. Thank you for your attention, and bye-bye. Stay safe.